Good morning, guys. So this is the second part of Lab 1. It's just a review day. And just a reminder for these exercises 7 and 8, this is review. And remember we used the website called Calculator Soup. And it was called prime factorization. All right, so just a reminder that you can use Calculator Soup prime factorization when you're simplifying square roots. Now, remember when it says square roots, that's specifically the root of 2, right? When there's no root number, there's actually a root of 2, and that's the smallest square. You can't have a first root. All right, so remember when you do these, basically you break the number into primes, and I know that 18 is 9 times 2, which I could just use the 9, or I can use 3 squared. And since it's a square root, I'm looking for things to the second power or perfect squares. So in this case, I could leave the x to the fourth as x to the fourth and just take it out as an x squared, or I can change it to x squared and x squared. And basically I pull out everything with a square. So you can break it down to these smallest components, or you can take some shortcuts if you're familiar with this. All right, so the final answer here would be 3x squared radical 2. All right, next one. So again, I know 200 is 100 times 2, or 2 times 10 squared. Calculator Soup would tell you it's 2 to the third times 5 squared. I'll just do it like that. You can, like I said, you can do it many ways. Since I have x to the fifth, I can break that down, and I can bring y cubed down into y squared times y. And again, this is review, so I'm not really going too in depth. The 2 to the third we can change to 2 squared times 2. And then anything that has a squared value with it comes out. So I have 2 times 5, which is 10. And then I have x squared y. So my final answer would be 10x squared y. And then the square root of 2xy would remain. All right, and if you're fluent with your perfect squares, you can just say, okay, I know this is 100 times 2. You can leave x to the fifth as x to the fourth times x, and y to the cubed is y squared times y. And you can also do it like that. Okay, I know the square root of 100 is 10. I know the square root of x to the fourth is x squared. I know the square root of y squared is y. And then I have the 2xy remaining. So depending on your the level of comfortableness, I guess, how comfortable you are, you can do it either way. You don't have to use the prime factorization on Calculator Soup. All right, 147. All right, I know that's 49 times 3, which would be 7 squared times 3, or 3 times 7 squared. So Calculator Soup would tell me 3 times 7 squared. And again, x to the ninth, I could put x squared times x squared times x squared times x squared times x, or I can just turn it into an even exponent, which is a perfect square, so I could do x to the eighth times x times y to the fourth. All right, so my 7 squared comes out as a 7. The square root of x to the 8th, I'm just going to cut that in half. It's going to be x to the 4th. And then the square root of y to the 4th is y squared. And I have 3x remaining. All right, so there's some of these on your homework. Let me circle that one too. Exercise 8, now we're going with higher order roots. Notice all of these are triples, or they're third roots, fourth roots, and actually fifth roots. So if I'm using Calculator Soup, I just want to pull out things to the third power. And again, this is review. We've already done this. I know 16 is 2 to the fourth. So if I want, I can write it times 2 to the third times 2. So since I'm taking a cubed root, I can take anything to the third power out, like I stated. So this is going to be 2 times the cubed root of 2. And just don't forget to write that root number in there in your final answer, because if you don't write the 3, it's wrong, because there's no number in there. It's indicating it's a square root. All right, for 108, Okay, let me see. 108, half of 108 is 54. So it'd be 54 times 2, and 54 is, 54 is 9 times 6. So 9 is 3 squared, 6 is 2 times 3. So this would be 3 to the third times 2 squared. 3 to the third is 27. 2 squared is 4. 27 times 4 is 108. So the only thing that can come out is the third power here. So it's going to be 3 and then the cubed root. And I just multiply my 2 squared. I put that back together as a 4. Okay, and this would be my final answer here. All right, next one, cubed root of 250. Well, I know 125 is 5 to the third. So 5 to the third times 2. So I can take this guy out and I get 5 times the cubed root of 2. And again, you can check all these on your calculator. If you type in 5 times the cubed root of 2 and you type in the cubed root of 250, it should come out to be equivalent values, the equivalent decimals. All right, so this is our first one of the variable with the cubed root. 128, I noticed that's 64 times 2. 64 is 8 squared. So that would be, let's see, 8 squared times 2. So 8 is actually 2 to the third, so it'd be 2 to the 6 times 2. 128 is 2 to the 7th. All right. I'm going to write it as 2 to the 6 times 2. And then when I see a cubed root, I can do any multiple of 3. So that's why I chose 2 to the 6. So 8, I'm going to do the same thing with x to the 6 times x squared. All right, so now basically I'm taking 2 groups of 3 out. So I would take 2 squared out here, or 4. I'll rewrite that in a minute. So that's going to come out as a 2 squared. This is going to come out as an x squared because there's 2 groups of 3 within that. And then I have the cubed root of 2x squared left. So I'm not going to leave it like that. I'm going to write it out as 4x squared times the cube root of 2x squared. All right. 4 more in this section. Okay, so now I'm doing the fourth root. 162, half of that's 81. And I know 81 is 9 squared, or 3 to the 4th. So this is 3 to the 4th, which is 81 times 2. Since I'm taking a 4th root, I can just take the 3 out. So it's 3 times the 4th root of 2. All right, next one. Hopefully you guys are getting to the point where you're fluent, where 16 is 2 to the 4th. And then x to the 8th, that's a multiple of 4, so I can leave it like that. I'm going to pull a 2 out. And since there's 2 groups of 4 here, I'm going to pull out an x squared. Since there's nothing left underneath the root, this is my final answer. I don't need my radical sign. All right, 4th root. So 48 is 16 times 3, so I'm right as 2 to the 4th times 3. I want my exponents to be multiples of 4, so it's x to the 8 times x squared, and y to the 5th, y to the 4th times y. So I'm going to take these out, and I end up with 2x squared y with the 4th root of 3x squared y remaining. Okay. One more for this section. This is my 5th root. I know that 64 is 2 to the 6th power, because 2 to the 5th power is 32. So I'm going to write it as 2 to the 5th times 2. I want multiples of 5, so I'm going to write it as x to the 10th times x squared. And y to the 15th is a multiple of 5, so I can leave it like that. All right, so I'm going to pull a 2 out. There's 2 groups of 5 here, so I'm going to pull out x squared. And I'm going to pull this out as y to the 3rd. And I have the 5th root of 2x squared remaining. So 2x squared y to the 3rd times the 5th root of 2x squared. All right, we've done the rest of this page. Okay, we skipped over that. This was review from earlier this year. So those are the notes for that. And now we're going to move on to pages 8 and 9. Sorry, I kind of skipped over that. All right, so your homework is actually going to be pages 8 and 9, and we're going to do part of number 20. So I'm just going to do like random ones on these pages with you, and your homework is to finish these 2 pages. All right, so rewrite the following by using fractional exponents. This should go pretty quickly for you. I'll just do G with you. All right, so remember, if you see a fraction, that just means that once I change this into a fraction, I can rewrite it as a negative. So it's x. Remember, the power goes on top. So in this case, the power is 2, and the root is on the bottom of the fraction. So 1 over x to the 2/3, which is the same as x to the negative 2/3 power. All right, so you're just going to go through and do finish number 12, the rest of the letters. Number 13, rewrite each of the following without fractional or negative exponents. They want you to use radicals. All right, so again, I'll pick one to do with you. How about letter F? I'll do one of the negative ones, which tends to be a little trickier. All right, I don't want fractional exponents or negative exponents. So I'm going to create a fraction. I'm not going to have a fractional exponent, but I'm going to have a fraction. So right now, the middle step, I'm going to say this is the same as 1 over x to the 7/2. But I don't want a fractional exponent. I want to rewrite that as a root. Okay, so my x is my radicand. The power is 7. And since the root is 2, I don't have to write a 2. Okay, it's assumed it is a square root if I have no number there. So it's just 1 over the square root of x to the 7th. All right, so finish that section. All right, number 14, it says simplify each of the square roots that contains variables in the radicand. All right, this is what we just did in exercises 8 and 9. We did that extensively, so you guys should be all set. They're all square roots, so it's a root of 2, right? For these, that was the same as exercise 7. We just started working with square roots. So simplify the square roots. Number 15, it's the same thing that we did. Now the roots are higher. This was like exercise 8, so you guys should be all set with that. Number 16, rewrite these with a radical sign. I just want to point out that, answers D and E are going to be different. If you see the whole thing 3a's to the 1/2 power, then the whole thing needs to be to the power of 1 and the root of 2. So the whole thing would be underneath the square root sign in this case. All right. Since this only has a power of 1, you could just rewrite it as the square root of 3a. But to be safe, you might just want to put parentheses around it. It's the same thing. All right, so watch out for those parentheses. Number 17, use exponents to write the radical expression. All right, let's see. So instead of the root, they want a radical. How about G? I'll do G with you. This would be x times, okay, y to the power over, oops, I just made a huge mistake. That should be a second power, right? Or root of 2. There's no such thing as a root of 1. What was I thinking? All right, so the power is 3 and the root is 2. And that's all I can do with this. So it's just x, y, hold on a second. X, y to the 3/2. Okay, I just leave my answer like that. For H and I, that negative sign out front does not affect, it doesn't mean it's a negative exponent or anything. It's just the value will be negative, so this just drops down. And in this case, the power is 1 and the root is 3. So just be negative 2 to the 1/3. Okay, so that negative does not affect my exponent. All right, number 18, evaluate the given expression. I'll just do like a couple of these with you. F, okay. Remember, when I'm multiplying, I keep the base. So the base is going to stay 2, and I add the exponents. So 1/2 plus 3/2 is 4/2. and 4 halves is the same as 2. So this is the same as 2 squared, which just reduces to 4. Okay, so you might have to do a few steps there to get to the final answer. And I'll do, let's see, I'll do J with you, okay? So order of operations, we're going to simplify parentheses first. Within parentheses, I see exponents. So 3 to the 0 power is 1. Okay, now I can add 1 plus 3 is 4. So I'm doing 4 to the negative 1/2. I know a negative exponent means that's the same as 1 over 4 to the 1/2 power. And I know 4 to the 1/2 power just means the square root of 4. So my final answer here would be 1/2. All right, and the last part of this, we're going to skip over all the equations. We're going to do that in the third part of this lab. Okay, this lab we're actually splitting into 3 pieces. So we're doing number 20 is the last part of your homework to finish number 20. All right, and I'll just do a couple of these with you. Notice it's hard to see this whole bottom row has negatives. Okay, negative exponents. So just, it's kind of hard to see. All right, so I'll do a couple of them with you. How about I do G and H with you? So again, this is the same as, first of all, 1 over 3x, and the whole 3x is to the b over 4 power. All right, and I'm going to write this with the roots. So this is the same as 1 over, okay, so 3x is underneath the radicand. The power is b and the root is 4. So if I want to take 3x to the b power, I need to put it in parentheses, and the root value is 4. So that's how we'd write that one. Let me just fix that 4. It looks kind of messy. Zoom in to write a little neater. Perfect. All right, and then this one, only the x is taken to that power. So this one, the 3 is going to stay on the numerator, and the x moves to the denominator. And when we move it, we put it to the positive fractional power. Okay, so we're not done yet. I want to write that in root form. So in this case, like I said, 3 stays on top, and now we have x has a power of b and a root of 4. So this would be my final answer for this one. All right, so your job is to finish everything we left blank. You can skip, accept all the equations. That's going to be next class. Negatives. All right, have fun, and you know where to find me for help. Just an email away. And